All right, let's get into it. So, right now, the kinds of saving questions you guys have done is like you put in a bit of money, you wait a long time, it gets interest, and then you withdraw that money. That's not really how people save for stuff, right? If you want to save for some big purchase, you're not gonna like. If I want to save up for, um, uh, let's use you guys as an example. You guys are maybe 2 or 3 years away from doing a post-secondary program. Let's say you want to save up a chunk of cash for that. You want to save up, I don't know, like $10,000 from your part-time job. Like nobody has like $7,000 to invest right now, so they can have 10,000 in the future. Right now, we have nothing. So what people do is you put.
Good morning, Active District. I just want to welcome everybody back and take a few moments to go over a couple of protocols and
Back to recording. So yeah, what happens with our saving is you start with nothing and you put away little bits over time, and over time that grows to your savings goal. So we're going to use this as a bit of a motivation problem. So we're counting on Grandma to give us $100 every Christmas. Instead of spending that money, you decide for the next 5 years, or for 5 years starting at Christmas, you're going to deposit that money into a savings account. And so we're updating our way of saving here. We're not just putting in a big sum of money up at once. We're putting in a little bit at a time. Let's look at how this works. So we're going to put the money. We're going to keep things simple in an account that pays 5% compounded annually. Let's look at how much we'd have after 5 years. We're going to do this several ways. Let's start with today. So it's January 1st. Let's say. The whole year goes by. It's Christmas time. Grandma gives us $100 at Christmas, roughly the end of the year. So this $100 at the end of 1 year, if you guys look, it has 1, 2, 3, 4 years to grow. This guy after second years, 1, 2 has 3 years to grow. The deposit after 3 years only has 2 years to grow. The one after 4 years, 1 year to grow. The one after 5 years, at the end of 5 years, when you deposit that $500 or that $100, it doesn't have time to gain interest. That $100 is just worth $100. But the one you deposited after 4 years has had 1 year to gain interest. And how do we calculate that value? Like we've been doing, we'll do 100. We're keeping things simple here. It's 5% interest compounded annually. So we literally will multiply that by 1.05. I can do that math. That's $105. And here's the thing. Every deposit, the longer it's been in there, the more it's going to be worth. It's had more time to collect interest. How much is the deposit after 3 years worth? You guys can keep going if you see the idea. What's the calculation for that one? How much would that deposit be worth? It's had 2 years to grow. Be worth 100 times 1.05 squared. Whatever that is. So I'd like you guys to get that one, and then you guys need to calculate how much is the 2 years deposit worth. It has had 3 years to grow. And finally, how much is the first deposit worth? It has had 4 years to grow. Again, we're depositing at the end of the year. That's why none of these has 5 years to grow. Yeah, looking pretty good there. Probably zoom in the tiniest bit more, actually. No, I can't. Nearest set as usual. I got 110.25. And if you're wondering, oh, Mr. Smith, this seems kind of tedious to do all the time. It is tedious, but it just shows you what's going on. This is the last time we'll use a timeline. We'll develop tools to do it other ways in just a few moments. To the nearest cent, I got 115.76. And for the first deposit, bless you, I got 121.55. Seems reasonable. I'll trust you guys to let me know if there's a slight miscalculation, but it seems pretty good. And so if we want to know, okay, well, now how much do I have after making these 5 deposits of 100? Now we can just add them up. In reality, these are all mixed into the same bank account. Let's add them up. 100 plus 105 plus 110.25. I'm already tired of timelines. Let's get to the technology. 115.76 plus 121.55. Okay, how much is that? This answer seems very reasonable. 552.56. But I actually don't need to ask you guys if I did it right because we're going to check it using technology. Um, what we just did, this series of regular deposits, is called an annuity. Specifically, this is a simple, ordinary annuity. An annuity is just a series of regular deposits. So in this case, it was $100 every Christmas. If for people saving for retirement, it might be a certain chunk of money every time they get paid. It is in our cases, we're going to be making deposits at the end of a compounding period, and we're going to be keeping things simple, meaning we make deposits every year, interest is calculated every year. In questions where we make deposits every month, interest is calculated every month. And that will be true for all of our problems the next few days. In general, we have 3 ways we can do this. 1, we could use a timeline like we did above. We just did that, but it kind of sucked. In this course, we do 2 more methods. I'm going to show you guys how to use our TVM solver to solve these kinds of problems. And I'm also going to show you guys a formula. Part of this course is connecting the financial math to our previous unit, sequences and series. So I show you guys formulas to do this as well. So let's do the second method right now. We're going to use a TVM solver. As I said earlier, most people I teach these days are just using a TVM solver on their phone. I have Chromebooks at the back, lots of options for you guys. I have the link to this in the news feed, but you should have a TVM solver open. As usual, when doing a note, I'll fill in the TVM solver, circle what I want, and then just do the find the answer on the TVM solver. What is different about these kinds of questions, though? I've prompted you guys to change in the blank TVM solver screen there. When doing annuity problems, there's a big change. N is not years. We're going to use N for deposits. In this case, N is 5, which is the years, but only because you're making yearly deposits. So keep that in mind. I is still our friendly interest rate, whole percent, 5. In these annuity questions, PV is going to be 0. 0 because we're starting with nothing. And now we're going to be making use of the PMT section. We didn't before. PMT stands for payment. How much is our regular payment here? It's how much are we depositing. And because we're depositing it, we're giving the money away. We can pop in negative 100. If you put in positive 100, not a huge deal. You're just going to have the opposite sign for the future value. It'll give you the same numerical answer. But as I've been telling you guys, we would like to get be accurate. I would like you guys to use the proper signs. It will be important a little bit later. But for now, you can get away with it. We're solving for FV. And now we're making use of the PPY section. Payments per year. We're making 1 deposit per year, and interest in this question is done annually. So its CPY is 1 as well. For now, I'm going to add a little prompt here. For now, PPY and CPY are always going to match. And that's it. So let's dive in. If you need assistance, like getting the link open, or you can't do that, like just let me know. But yeah, I've provided the Chromebooks at the back. You can feel free to get up and grab one if you want. You have your own device, but I'll just assume at this point you've pulled up a TVM solver screen if you're going to, and you have one that works for you. So here we go. Let's just slam this in and see what's up. So 5, PV is 0, EMT minus 100. Now, you guys can correct me if I'm wrong. I don't know if I'm misremembering, but in my mixed course has been doing this since before the break a little bit. And at times, some people had some finicky issues putting in negatives. Can you guys put in negative 100? Can you guys put in positive 100? Just put in positive 100. Everything will be okay. I'll do the same thing with you guys. We'll put in positive 100. Everything will be okay. And PPY, CPY is 1, and we just click for solve for FV. Hopefully, it's the same as we got from the timeline. Otherwise, everything will be awful, and we should just quit for the day. But no, we get the same result, 5, 52, 56, just like we found with the timeline. Technology is amazing. So I'll just pop that in, 5, 52, 56. Of course, I'm using my tablet, so I'll lose my cursor several times. Here it is, 552, 56. Of course, tablet is not working. 5, 52, 56. All right. Life is good. So you can use a timeline. You can use a TVM solver. Some courses, that's the requirement. They don't have to find any other tools to do this. You guys, though, in the 3U course, do have the tools to develop a formula for finding a future value. And we're going to derive it right now. It's going to be great. So let's look at the grandma example and develop a formula for this. So what did each deposit look like? The last deposit was $100. The second last deposit, its future value, we got by doing 100 times 1.05. And then all the way up to the one that was worth the most was 100 times 1.05 to the power of 4. That right there is a sequence, and it's a special type of sequence. We're multiplying by the same common ratio every time. This is a geometric sequence. And what we did when we added up all of Grandma's deposits, what we were doing was we are finding the sum of this geometric series of these 5 terms, these 5 deposits. It's a geometric sequence. The first term is 100. A is 100. What's R? Well, R is 1.05. That's what we're multiplying these future values by each time. And how many deposits were there? There were 5. We can get the same grandma result by using our sum of a geometric series formula. It's okay if you do not have this memorized. I gave it to you guys on your assignment. I'll give it to you now. The sum of a geometric series was Sn equals A times R to the power of n minus 1 all over R minus 1. Let's give this a spin and see if we get the same result. Spoiler alert, we should. So A is 100, 1.05 to the power of 5 minus 1, all over 1.05 minus 1. My advice would be do everything at once. If you're using your phone as a calculator, I'm not sure they're going to be nice to you and let you do that. So you might want to do, like, say, do the top, and then do the bottom, and then divide the two. Just keep a lot of accuracy. I'll just let you guys make your own decision on that. 1.05 to the power of 5 minus 1 times 100 divided by 0.05. Okay, I got the same thing. 552.56. 552.56. So nice thing about this, guys, we're going to be developing formulas to use with our financial math, but any of these questions can be checked with the TVM solver. Life is good. Now that was for the grandma specific problem. What we'd like to do is develop a formula that we can just use all the time. And that's what we're going to do on the right side here. We're going to take what we just did with the grandma example and generalize it. So I think I can just do that and go up a little bit. Yeah, we're good. Okay, so we're going to generalize this process. The symbol I'm going to use for the deposit, the one your text uses, most courses use, is a capital R. I don't know why capital R. Maybe there's some French word for payment or something. I don't know. But the first or the final deposit or the deposit amount we're going to call R. The next to last deposit has one compounding period to grow. So it's going to be worth R times 1 plus little I, the same little I from our compound interest formula we worked with the previous week. The next guy will have two compounding periods to grow, R plus or R times 1 plus I squared. The final deposit will look like this. R times 1 plus I. But remember with the grandma example, for 5 years, that first deposit only had 4 years to grow. In general, if there's n deposits, the very first one only has n minus 1 compounding periods to grow. So the cool thing of what we can do is we can see for this generalized sequence, we can see the first term, we can see what we're multiplying by, we know how many terms, we can actually develop a formula where we can just plug this stuff in and just use this all the time. It's going to be great. So the first term, we're using the variable r. The common ratio is we're multiplying by 1 plus little I, the interest rate per compounding period. The number of terms, n, is just we're using n. And so let's derive a formula, and then you guys can just use the formula. You'll never have to rederive this guy. So for a geometric series, a times r to the power of n minus 1 all over r minus 1. Let's plug our stuff in and simplify a little bit, and then we'll have our formula. Again, we can just use all the time. So we're replacing little a with capital R, our payment amount. I'm going to set up some square brackets here. Little r is 1 plus I to the power of n minus 1. And on the bottom, we have little r is 1 plus I minus 1. A little bit of a hefty formula. We can actually clean that up a little bit. If you look at the bottom, you have 1 plus I, and then you're subtracting 1. So 1 minus 1 is 0. They actually go away. And this is the formula. And actually, I do want to make one more thing in the second line here. I'm going to replace Sn with A, our symbol for future value. And we've got our first formula, the future value formula, the future value of an annuity, a series of regular deposits. You take the payment amount, R, you multiply that by 1 plus I to the power of n minus 1, and you divide by little I. Is it easier than using a TVM solver? No, absolutely. We'd use a TVM solver. But how does a TVM solver calculate it? It uses this formula. And again, guys, this is just part of your course. Other courses, the college level course, the mixed level course, they would do these problems just using a TVM solver. But because you guys have the math background, part of the course is making this connection. And so now we can do these problems a wide variety of ways. Formula, timeline, TVM solver, and we're just going to play around with these a little bit. do some examples, and see the power of compound interest. And the questions we're going to do now, in my opinion, relevant to you guys, hopefully convince you that, hey, saving is a good idea. So we're going to do some of these examples just with technology. We're going to do some of these with the formula and technology. This one, pure tech. Let's do it. What if you put $1 away every week for 50 years? So you guys would be, I guess, like 66, 67-ish at the end of 50 years. What if you decided right now, $1? We're going to assume we're going to get 12% compounded weekly. That's pretty high. However, if you're investing in something where you're not going to touch it and you're going to leave it for 50 years, you can actually get a really good interest rate like that. Something like the stock market, which kind of does fluctuate, but in general does go up by a lot every year. So 12% seems high, but not too unlikely. How much could you have in the end? Well, we know how to handle this. First things first, though, the one thing we have to be careful of, n is not years. We're not putting n equals 50. We got to figure out how many times are we depositing $1. 50 years of weekly deposits. Well, weekly means 52, right? We're making 52 deposits per year. 52 interest is calculated 52 times a year. How many deposits is that? That's 50 years of weekly deposits. I think that's $2,600, but I'm going to check. 50 times 52. Of course it is. We are making 2,600 deposits of $1. 12%, start with nothing. I'm going to continue on my sheet to use proper signs, PMT -1. I get if you're using the TVM solver on a mobile, you have to put in +1. It's okay. We're going to get the same. We're going to get the correct dollar amount in the end. Let's solve for future value. Let's see if maybe the answer surprises you. Maybe it doesn't. So 2,600, 12. I think I can zoom in on this. Yeah, I can. 12. Start with nothing. PMT. You guys can just put in 1. That's okay. Change PPY to 52. You also have to change C/Y to 52 manually. I think we're set up. We're good to go. I'll have a sip of coffee while you guys get that queued up. Actually, I'll do my attendance too. Okay. Okay. Good stuff. Here I come. Solve for FV. Okay. Got it. Did you guys get that same thing? 107. That's quite impressive. $173,181.55. I'm 40 now. I can definitely not remember that number. I'll have to come back and look at it again. 173, 181, 173, 181. 55? Was it 55? Yes. 55. All right. Now let's think about this, guys. How much of our own money did we deposit over these 50 years? You don't have to think too hard. I'll write this down because we can do this method for later problems. We made 2,600 deposits of $1. If you multiply those of your own money, you put in $2,600. You finish off with about $173,000. How much interest did you make? Like mostly all of that is interest, but we can find how much interest we made by taking the difference 173, 180, 155, and subtracting how much of our own money we put in, minus 2,600. Like it's pretty much all interest, but that's how we would do it. Minus 2,600. Fascinating. This isn't made up stuff. This is real. This is real math here. This could be you. 581.55 in interest. The power of saving. I think most of us, well, if you work a part-time job anyway, pretty sure you could probably find $1 a week. The great thing about TVM solvers is you guys don't have to copy this down. What if you're like, Mr. Smith, that 12% so unrealistic? I'm like, okay. What if the interest rate, let's say it's 10, but let's say you could do $5 a week. Could you do $5 a week? I feel like one of those infomercials. Like, you just donate $5 a week for the price of a cup of coffee. What if it was five? Resolve for FV. You can do it as well if you'd like. But exact same scenario, just $5 a week, 10%, solve for FV. $381,000, 425, 80, almost $400,000. Like currently, that's like 4 years of a very decent salary just by putting $5 a week away. So yeah, power of compound interest, very interesting. All right, let's head back to the note. Let's do another very realistic, helpful scenario, planning for retirement. So you guys are going to, like some of you guys right out of high school might get into an apprenticeship, might start working right away, can start saving right away. My brother-in-law Ryan finished high school right away, got into a millwright apprenticeship, and he's been doing that since. He's been working since he was 18. Me, I did 8 years of school, and I started working teaching when I was like 28. I had like part-time jobs, but so everybody's gonna be a bit different. But once you start working, it's very beneficial to start saving for retirement. Jim is investing $300 every month into an RSP. You may have heard this before. It's just a fancy word for saying, or it's an acronym for Registered Retirement Savings Plan. Jim gets a pretty decent interest rate, 7.2%. Again, because he's just letting it grow. He's not touching it. And so when you do that, you can get really good interest rates. He's making deposits every month. So in our annuity questions, that means interest is calculated monthly. How much will Jim have when he retires in 40 years? Let's use technology first, and then we'll give our formula a spin. Okay? So let's use the solver. It's a monthly question, so 12 and 12 can be pumped in right away. How many deposits is he making? Again, we just have to be careful there. So Jim is working for 40 years, making monthly deposits 40 times 12, 480. Interest rate, 7.2. We start with nothing in these kind of problems. Jim invests $300. Again, if you're on your phone, just put in positive 300. It's okay. You'll get the right numerical value. Solve for FV. We'll actually do the TVM solver and then do B and C and then use the formula as the last thing we do with this question. All right, I'm going to come along for the ride here. 480. 7.2. PV is 0. Jim is putting 300 away. Monthly, 12 and 12. Solve for FV. Boom. Okay, what do we got here? About $833,000. This isn't made up. Jim almost has $1 million saved up for his retirement. Fantastic. Now you might be like saying, well, yeah, that's a lot of money, but $300 a month, that is also a lot of money. So it's will be good for us, beneficial to do a fair comparison, like the last example. How much of our own money did we put in? How much interest did we make? So let me get that down. 833,000. Already forgot the next digits. 81 and the cents. 43. 81.43. Just note that when we use the formula, it's nice to know what the answer should be so we can check. But yeah, how much did Jim deposit over those 40 years? Well, you guys now know how to do this. He made 480 deposits of $300. So yeah, that is a lot of money. But let's see how much. For 80 times 300. Okay. Okay, Jim. Okay. Okay, Jim. Okay. $144,000. So yeah, it did take a sacrifice on Jim's part. $300 a month is a large sum of money. $144,000 is a lot of money for Jim to kind of temporarily sacrifice. But let's look at the benefits, the interest. Let's compare. He finishes with roughly $833,000, but he only invested $144,000 of his own money. Let's find the difference and let's find the interest. The balance of this is all free money, interest. Oh, 81.43. We could ballpark an estimate, but we'll keep using dollars and cents. 689,000 and 81.43 in interest. Pretty good. Pretty good. Anything you guys want to chat about regarding what we just did? We now have a couple examples doing an annuity problem on the TVM solver. Okay, we'll make some tweaks with that in a second, but let's take the future value of an annuity formula for a spin. What are our parameters in Jim's problem? Well, his payment amount is 300. You don't need to worry about signs using the formula. His deposit amount is 300. Little I, you guys know how to calculate little I and little n. It's the same as it always is. We take the yearly interest rate, which is 7.2% as a decimal, 0.072. This is a monthly problem, so you divide that by 12. And I cooked this one up to work out nice, 0.006. It will be our value for little I. In our value for little n, we actually did this work in the TVM solver, but it's 40 years compounded monthly. 40 times 12 is 480. Interest will be calculated 480 times. So it's a new formula, but it's nice to know that the things in the formula are just things we've already worked with. All right, guys, let's take it for a ride. A equals R times 1 plus I to the n minus 1 divided by I. We should get the same value. Again, some of you guys may want to break this up into smaller chunks. I would just keep a ton of accuracy. Ideally, you have a scientific calculator, and you can just use brackets and just do this all at once. 1.006 to the power of 480 minus 1, and then divided by 0.006. You know what, too? If like whatever you're using can store an answer, then just do 1.06. It's 1.006 to the power of 480. Then subtract 1. Then multiply that answer by 300. Then divide by 0.006. I'm not your dad. Do what you want, but that's one thing you do. Yeah, just keep a lot of accuracy because once you introduce some rounding, then you're going to reduce the accuracy. And often with in this question with a large answer, rounding to the nearest cent, a little bit of rounding can go a long way to changing the answer. Times 300, moment of truth divided by 0.006. Okay, I got the same thing. As we should, 833, 81, 43. Okay, are we doing the formula again? Yeah, we're using the formula one more time. And just looking ahead, I think, okay, here's what we're going to do, guys. For part D, we're going to make a tweak with the TVM solver. And then we're going to use the formula. But for the back, the last question, we'll just use the TVM solver and we'll just wrap it up. So let's make a tweak. What if I wanted to have the same amount saved up, but after 30 years instead? What would I need to invest each month? So think of it this way. What if I started working? Oh, I guess Jim is like Jim Smith, Mr. Jim Smith. Mr. Jim Smith. Like, what if Jim started working and was like, I would like to just live life and spend my $300. I don't want to save it right now. And then kind of wised up 10 years later and then started saving. So what if he waited 10 years to start saving? We're going to see, well, how much would he have to save now in order to catch up, in a sense? So let's do it. So it's 30 years of monthly deposits now. 30 times 12 is 360. Same interest rate, 7.2, starting with nothing, PV equals 0. In this question, we are looking for what he needs to invest each month. So we're solving for something different. Here we're solving for PMT. We know what the future value is, the same as the previous question. So 833, 171. No, that's wrong. 833, I was trying to go from memory, but yeah, old. 833, 81, 43. PPY and CPY, 12 and 12. So can you guys make that change? Beauty thing of a TVM solver. We just did this question. There's nothing for you guys to do except change N to 360 and then just go down and click on solve for PMT. Love TVM solvers. This is amazing, guys. Well, it's not amazing for Jim, but by just waiting 10 years to start saving, to catch up and have the same amount, he now has to invest more than double what he was paying per month, 656.37. It's just demonstrating, guys, the importance of starting early. So 656.37. 656.37. And did you guys get the same thing? Okay, good. I do want to show you guys how to use the formula. Maybe you're asking, well, how do we use the formula? The formula solves for A. How do I use the formula to solve for R? Well, we just do a bit of rearranging, and I'm going to show you guys how to do that right now. So we're going to start with the future value formula. A equals R times 1 plus I to the power of little n minus 1 all over I. We're going to go right to the rearranged formula. It's actually not that hard to rearrange for you guys. If you want to get the R by itself, you got to multiply up this little I, and you got to divide by everything in that square bracket, and that will get R by itself. And like, there's literally not too much to show. To get R, you take A and you multiply by little I, and then you divide by all that stuff. 1 plus I to the power of n minus 1. And there we have it. And now that's just another derived formula that you guys can use forever and ever. Amen. What are we plugging in? So I'll just write this off to the side here. A, our future value, we're using the same amount that he had before when planning for retirement, $833,081.43. What are we using for little I? Same as the previous question, 0.006. And what are we using for little n? We did this in the TVM solver, but it's 30 years of monthly deposits, 360. So again, we still calculate little I and little n the same way. Let's plug in and let's give this a try. We know what we should get. This will be great for you guys doing your case study performance task. Hypothetically, let's say I asked you guys to do it two ways, using the formula, using the solver. You can do it using the solver. You can set the formula and say, hey, I plugged it in. Sure, Mr. Smith, I got the same thing. So you can just fake me out. But it would be good if you just try it. Make sure you can do it. Hope you guys realize where our financial math stuff right now, our performance tasks, we're into the final and like the final 30 stuff, right? And you guys did hear that all the final 30 stuff can't negatively affect your mark, right? Did you guys hear that? You guys heard that, right? I see nods. Yeah. So we're low stress here. We're learning. We're trying our best. We're trying to improve our mark. But it's stress free right now. Your mark can't go down from just giving this stuff a try. So just give it a try. Make your mark go up. Okay, and then on the bottom, we have 1.006 to the power of 360 minus 1. So again, if you do it in a couple steps, keep as much accuracy as possible, or use a scientific calculator, make use of brackets or what have you. I might do it in 2 steps just to show you guys what that might look like. So if you do the top, and I'm going to keep all the accuracy my calculator gives me. If you do this in 1 step, good for you. 4,998.48858. Like, I'm just keeping all the accuracy just to show you guys. The bottom, I can do that at once. That's not too bad. It's power of 360. 1.006 to the power of 360 minus 1. On the bottom, I get 7.61535263. And if I divide those two numbers, I should get the result we got from the TVM solver. Again, preferable just to do this at 1 step. But if you're doing it in multiple steps, this is what you should do. Just keep all accuracy. 2653. Boom. 656.37. And this would be per month. Okay, good stuff. You guys have a variety of tools now to solve these kind of problems. You can use a TVM solver. You can use our newly derived formulas. And we now can handle a few different types of retirement questions. Like, if I save this much, how much will I have in the future? Or, if this is my goal, how much do I have to invest per month? You guys can do 2 different types of questions. Here's a third. But we are not going to use the formula. We are going to do this on the TVM solver, and then and then we'll just call this lesson done. So Oliver plans to invest $2,000 quarterly for 5 years. His investment will grow to just over $45,000 after the 5 years. But Oliver's interested in finding out what this rate of interest is, because then he maybe could shop around and see if some other bank would give him a better interest rate. So this is often what financial advisors or people trying to sell you products, they might tell you just what you'll have after the 5 years instead of telling you a rate, because then you can't shop around. Then you might just say, "Oh, that sounds good. Sign me up." So we're finding the interest rate. We're finding I. Given it's 5 years quarterly, So we know means 4 times per year. So he's making 2,000, or sorry, he's making 20 deposits of $2,000. Starts with nothing, depositing $2,000. Investment grows to 45,682.40, and it's a quarterly problem, so it's 4 and 4. Now, I'm wondering, are you guys allowed to put in a negative for anything on this TVM solver? You can't put it in for anywhere? Okay. Once we finish this problem, I'll troubleshoot and I'll get you guys a mobile friendly one because we'll have to sort that out. No big deal though. Now, let me ask you guys, when you guys are at home, maybe have this up in a separate tab. You guys could do negatives? Okay, so it's the mobile version that's the issue, right? Okay. Well, that's good to know. Easily fixed. Actually, I should just clear all this out. Well, this is no fun. You're just watching me do this. We're finding the interest rate. Start with nothing. PMT minus 2,000. 4568240. 45,682.40, and this is a quarterly question. Solve for the percent. So he's getting about 5.5%. Again, the importance of this is so that Oliver can now go shop around instead of just signing up on the spot. Maybe he can do better. 5.5. Let me just make a little concluding statement here. I don't know why I've been writing my concluding statements. I can just type them. He is getting an annual interest rate of 5.5%. Okay, so we've derived some formulas we can use to do these updated savings problems, regular deposits over time, and annuity. You're now trained up on using a TVM solver to do these kind of problems. Tomorrow we'll do problems where you've saved up this money, but now you want to withdraw it, and now you want to make that money last over time and start living off of that money. My expectations of you guys when you do your case study next week is that you guys can solve for FV or the payment, like so the future value or the payment, using a formula or the TVM solver. Anything else would be just the TVM solver. So those would be my expectations of you guys. And again, we're stress free. Mark cannot go down because of our financial math stuff. It can only go up. I have some suggested practice for you guys. Now, I have suggested, use the formula a little bit and use the TVM solver to check. I would just say, once you feel good using the formula, then just use the TVM solver. Just practice as much as you need to get good. Yeah, you guys have everything you need now to get started. I'm going to stop the screencastify.